Welcome back, guys. So here we stopped in our previous session, Android use of trust zone or TZ zone or TZ. So we have seen a small example as well of installing a third-party application in our mobile, Android mobile. So what are the things will happen in the backend? So that is what we have highlighted in this diagram, and we discussed how it works in the backend. So to conclude with that particular topic, so over here, trust zone is important. Nothing but you're supposed to secure your kernel level or implementation level, because of no third party can access that particular layer, so that no third party can intervene or look at into your own mobile phone without knowing you. So that's why he's asking if each and every time whether you are allowed to download it or whether you are allowed to implement it. Right, that is how it works. So that is how the use of trust zone of Solaris or even of Android as well. So okay, we will continue further. We'll see ARM CPU architecture. Consider we have a number of exceptions, right? Exception in the sense uh, based on the user, based on the application, the particular application wanted to implement or wanted to install and use whatever the data or object is available in the machine. So for in that particular perspective, we'll see a small example over here. So we know something like different applications in the topmost layer. It is user interface, something like UI or user level. On the other hand, if you can see, it is nothing but a number of users can install the applications in their own machines, either laptop or desktop. So now we are considering ARM CPU architecture. So with respect to that ARM CPU, so in top we have the exception level 0, nothing but user level exception or user dependent exceptions. Then we have exception level 1, that is kernel level, exception level 2, that is hypervisor, and exception level 3, that is secure monitor. So we'll see with an example. So we'll come back to the topmost layer once again. So that is user level. So with respect to user level, an user can install n number of applications on his or her own laptop or desktop machine. So now consider from the left hand side, just follow my cursor on the screen. So exception level 0, that is user level. So user may install applications or apps from 0 to n. So what is it? First 0 means one number of applications installed by one particular user. So the first 0 corresponds to first user, 0th user with n number of application. Just follow my cursor along with application 1, second user with again a number of application, and so on, so that user can install n number of applications on his or her machines. So now while selecting this particular application, user will decide what type of privileges that we can give. We'll see with another example as well. Let us continue with this. So now with respect to that, the topmost layer, that is user level layer. So exceptions are nothing but either the user wanted to install this one or no. By installing, what are the privileges that a user can provide is kernel level or main OS level. Nothing but using that application or using the operating system, user allows the particular application to install in his machine. So to install with that, the application supposed to contact with the OS kernel via how to contact. We have seen in the last class or last discussion, right? Via APIs or system calls. So each application will have its own API, application program interface. An interface should be set up from application level to the kernel level. So now what happens is when the request is given by the user to install, so it will contact the operating system kernel. If the kernel allows, so how this allowing or permission is given, whether the user is trusted with that particular application. If it is okay with that, then the next step is something like supervision or hypervision. So hypervisor's task is to install that particular API using a secure monitor, and if something happens, if other than any other installation, any other work is going on the backend, it should alert the kernel saying that this particular application is accessing the particular folder that is designated for whether you permit or no. So based on that, it is provided. So secure monitor will look after all these installation kind of thing. So secure monitor's job is to look after all those activities. So now each this particular set of activities from user level to the internal kernel level, then hypervisor level. Through hypervisor, secure monitor will look after all this setup so that the protection is given. So we are concentrating more on protection. So now from this exception level 0 to exception level 1, there is a one layer of protection. Either you may given with the username and password, that is you're supposed to log in into your machine. That is what the initial setup protection. From that kernel level, again it will ask you with a message box or a prompt whether you're going to install, yes or no. If it is selected, move on to hypervisor. Hypervisor will give the task to the secure monitor. So over here, with respect to EL3 or exception level 3, the secure monitor will look after all these exercises. So now with this, ARM will provide a secure monitor or secure zone to deal with protection of its data and objects. Hope you understood. We'll moving on further. So to deal with these kind of or levels of protection, we need domain. So domain is nothing but a group of processes, group of disks, anything. So over here we are dealing with protection. We can say domain of ring, multics. We'll continue. So rings of protection separate functions into domains and order them hierarchically. So we have seen rings of protection in the previous session itself. Yes. So more number of rings will give you more secure protection, more layered protection. So now each ring will provide separate functions for the domain. So what is the separate function is? The separate function is nothing but separate layer of protection. For example, so if you consider in general as an example, say for example, you're supposed to go to bank to deposit a money. So the bank is situated in the heart of a city. You're supposed to reach the city first. Then after you're supposed to locate the bank. So while reaching your bank, you may observe there is a person standing near the door, a security guard with his gun. That is first layer of security. After that, whether you're supposed to deposit next immediately. So it is again based on the bank. You may be intervened with any one of the clerks or help desk personnel. So they will ask you what you wanted to do with the bank, whether you wanted to deposit or withdraw. Second level of deposit, where again you're supposed to answer the query. The query is whether what is your choice, to deposit or to withdraw. That is second level protection. Next, once you answer that, he may guide you to the next level or next table where you wanted to deal with the exercise, either depositing or withdrawing. So you're going for a deposit. So you're supposed to give, you're supposed to fill pay in slip. Then along with the cash, you're supposed to count the denomination and make entries in the pay slip, then you're going to deposit it. So while depositing, again clerk will check with your currencies. Next level of protection. After that, again he'll check with your bank details, proper bank account, proper user credential like signatures. If everything is okay, then you are allowed to withdraw money or you're supposed to deposit the money. So this is the level or layer of protection. Same thing we can relate with separate function. So now with respect to computer, computer can have number of hardware objects and number of software objects. So computer must give protection for both hardware object as IO devices or software objects. Software object in the sense either it is applications, number of applications, or whatever the document you have. So there are documents are nothing but the outputs that is produced via one of the software application or software objects like files, documents, PPTs, programs, PDFs, all those. So now the computer must provide a protection for these kind of IO devices and software objects via providing some of the privileges. So now how to provide this one? Via providing processes. Nothing but each device is identified by its own process, its own object. So how it can be done? So for example, the process, if you consider, only the process may have access to objects it currently requires to complete its tasks. So now here we have something called some guideline. So one particular process is in execution in the sense that particular process is allowed to complete the task by utilizing one or the other hardware. For example, you wanted to print a sheet. You have 5 pages that is to be printed. So with respect to IO devices, you have keyboard, you have mouse, you have monitor, you have processor, there is nothing but CPU dabba, and along with the printer. So now you're supposed to print a document that is available in your mail. So what you do? So you log in, you switch on your machine, power on, your system will boot up. Then you're supposed to connect to the internet, check into your mail, download the PDF file, open it. So till here, you completed several processes. First process, you switch it on your machine. What's its job? It will alert RAM and it will find out bootloader. It will load the default operating system. After that, if you set up as a startup or startup program, automatically all the applications will boot up along with your OS. Automatically net will be connected. Then you're supposed to log into your mail. That is next process via using a browser. So browser is handled by another process once again. Then you're supposed to find out that particular file and download it. Once the download is ready, you will open that PDF. Again, you need a PDF opener or Acrobat reader, PDF reader. That is again another process. Is a software. Using PDF Acrobat reader or PDF reader, you opened that particular PDF file. So that is software object. So it is opened in the back end. Acrobat reader process should run. So now, so these kind of different activities, starting from the switching on till you open a particular file, then you're going to give a print. There are so many processes, involves both hardware objects and software objects. So now to provide the security with this, nothing but the machine or operating system will provide a number of processes to handle with these type of activity. So each individual activity is handled by one single process. So that is what we mean domain level of protection. So now we are trying to print the PDF doc that is already downloaded. So whenever you give Control P or print command, a process should run in the backend that should alert the printer to wake up from sleep. Once the printer is ready, you may hear a beep sound based on the printer once again, or some other sound of the tray sound saying that a tray is empty or you have enough paper to print. So that is a process. handled by one single process. So now this entire task, nothing but we are giving access to the processes to handle these kind of activities via hardware objects or software objects is called need to know principle. Nothing but each individual process will be running in the backend to complete one single task, saying that each hardware object and each software object supposed to deal with one single process for execution. For each software object, there should be an each process in the backend so that we can have a domain level protection. Continuing with that, an implementation can be via process operating in a protection domain. So how this implementation is occur? It specifies resources process may access. Each domain specifies set of objects and types of operations on them. Ability to execute an operation on an object is an access right. So now whatever the example we discussed so far, that is well suited with this. You're supposed to switch on your machine, open the browser, connect to your email, download a PDF document and give a print. So many resources should activate in the backend. Hardware resource as well as software resource. What are the hardware resources? Keyboard, mouse, monitor, printer. Then what are the software? Operating system, browser as an application. You download it. Then you're supposed to open that PDF document, viewer, PDF viewer, another software process or resource, software resource. Then you're supposed to print it. So these are the specific resources that should be specified to give a protection or domain level protection. So now to deal with that with respect to computing environment, we can say object name with its rights. Rights are nothing but privileges. So now we can have common access rights, common privileges, common priorities. Common hardwares can have read. Common hardwares can have write permission. Common hardwares can have both read, write, and execute permission as well based on usage. So that is how these domains may share access rights. Same access rights can be given to many of the devices, either hardware or software. Hardware as an object, software as an object. Then associations can be static or dynamic. So you can change the privileges or protection level once at a time. For example, for an entire machine. So say for example, only you are using your own machine. You are not at all allowing somebody else to touch with that. Then you may go with static. Because nothing to worry, no. Only you are dealing with your own machine. If it is dynamic, more number of users accessing that particular machine, then based on user also you can set up. Based on user level, based on hardware level, these things can be set up. Then if it is dynamic, processes can domain switch. We can switch different privileges based on the domain. So any clarification on this, please update or please raise your hand and you can clear your doubts later in the discussion. So how it can be the domain structure? So domain structure can be set based on like this access right with the object name and rights set. Over here, right set is nothing but a subset of all valid operations that can be performed on the particular object. So what are these right set? Nothing but either read, write, read, execute, anything out of these three with any combinations, read, write, and execute. So you can see an example over here. We have three domains, D1, D2, and D3. So D1 is having three objects, object 3, object 1, object 2. Please follow my cursor on the screen. Object 3, object 1, object 2. Object 3 is given with read and write as a set. So object 3 can be used for read write operation, saying that domain D1 is having three objects Each individual objects will have its own access right permissions. Access right permissions are object name, that is O3. Please follow the syntax. Object name, that is O3, with the right set, that is read comma write. Second object, object 1 will have read and write. Object 2 will have execute. That is one set. This is one single domain. Coming to the D2. D2. So D2 is having object 2 and object 4. Please consider, now forget about D3 for time being. D2 will have, please follow my cursor on the screen. D2 will have these two objects. So object 2 is having write, object 4 is having print. So now with respect to this, D2 as a domain which is having two objects, which two objects will have write and print write set or privileges. Consider D3. Forget about D2 for time being. Consider D3. D3 is a domain which is having three objects, object 1, object 3, object 4, which is having the write set, execute, read and print. So now in both D2 and D3 are common, that is print with respect to object 4. Both are sharing same object, both are printing, both domains are printing a particular document. So now that is what we discussed. So we can share the set of rights privileges with different domains or switching. So this particular switching can happen in between these objects. So we can implement, coming to the Unix session. So we'll discuss based on different versions, different OS levels, domain implementation. A domain is nothing but an user ID if you consider. So we'll considering a little bit broad criteria coming to Unix, as it is an open source setup, open source operating system. So we are considering that kind of facility. So now we are treat domain as an user ID. So domain switch accomplished via a file system. Each file has associated with it a domain bit or set UID bit, set user ID bit. When file is executed and set user ID is on, then the user ID is set to owner of the file being executed. When execution completes, user ID is reset. Consider an example. Say consider you are supposed to print a document which is having which is connected via a machine Unix operating system. Say Red Hat Linux machine. So now whenever you switch on a machine, it will by default Unix will ask you to log in. Either you may hide that particular setup or you may give a login credential. If there is a login credential, whenever you log in, you are given access to a particular file that is to be printed. So now that is what this particular point, second sub point says. When a file is executed and set UID on, what is set to UID? You are logging into the machine. You are setting up your user ID in on, saying that that particular user is using the machine or current user, we can say on the other hand. So then whatever that particular user does in that particular machine, he will be the owner by default. That is, then user ID set to owner of the file being executed. So you can create your own file, MS Word file, or you can create your own PPT, you can create your own PDF, whatever thing you can do. So you are the owner. And then when the execution comes, when you log off the machine, automatically your user ID will reset. So now this is the switching. So after that, second person may come in. So he may do the same exercise. So whatever he performs, second person may perform with the machine, that will be treated as his own file, and he will be the owner of that particular file. He will be the sole authenticated owner. So whenever execution completes, user ID will reset. Then, so how this can be done? Via passwords. Both persons may be given with the passwords. So with respect to Unix, you may familiar with su command, su command, super user. SU is in the sense super user. Super user command temporarily switches to another user's domain when other domains password are provided. So you are very much familiar with this one. So with respect, if you consider our college lab setup, one person can sit in one machine for a particular lab. So in the next session, next lab, another person may sit in the same machine. So in both the timings or in different timings, two persons or three persons may log in. So that's why by changing users, user domain using su command, su command. Then based on the command, so whenever you wanted to update your OS, whenever you want to install a particular application in your say Unix environment, so you may go ahead with the sudo. For example, sudo apt get command prefix execute specified command in another domain. So that is giving super user privileges. Now coming to the domain implementation with respect to Android application IDs. So with respect to Android, distinct user IDs can be provided on a application basis. Per application, you can have different IDs. So please look after this first point. However, we are very much familiar with the Android mobile. All are using Android smartphones. In Android smartphone, while installing any application, whether it's third party or provided by the same vendor or the manufacturer, each application will be created, or is whenever you install a particular application, automatically each application is allotted with the user ID. Either it may be phone number, either it may be your username, your designated username, or whether it may be your mobile name by default, or whether it may be your email. For each and every application, it needs user ID. That's why the term per application basis. Please remember, per application basis. While writing answers in the exam, this particular term is important. And then, so when an application is installed, the install ID or install daemon assigns it a distinct user ID and group ID along with the private data directory. So that is how it works: data, and app name. So these are the path whose ownership is granted to this UID and group ID combination alone. So I guess you understood the concept over here. When you try to install any application in your Android mobile, each and every time you're supposed to give your user ID and then designate a password for that. Otherwise, it will consider default. But on the other hand, in the backend, in the kernel level, for each application, a different UID is set up. And once you have that kind of setup, the applications, whatever you install in the device, that will enjoy the same level of protection provided by the Unix system. Right, the same level of protection. So this same level of protection is in the sense, while installing, you may give the access to everything, including your whatever the sensor you have in a mobile, gyroscope, camera, all those sensors with your database, camera folder, camera, all the folders, everything. So that is based on the level, the protection you are trying to give. And this is one of the method, the protection or by giving privileges or access. Oh yeah, the term access. A particular application wanted to access this particular folder, it may give you prompt. So this is how we can provide isolation, security, and privacy. So now, along with that, so you can extend by modifying the kernel to allow certain operations only to members of a particular group ID. So if you consider as an example, you can install any third-party application in your mobile if you allow developer option in your mobile phone. That's how it works. So you are going to extend by modifying the kernel level. Then one more thing is you can you have another option in that, right? Force stop. So if you go to settings, go to apps, in that you can list out a number of apps, whatever the apps running in the backend or whatever the apps you installed. So select any one, you'll get a two browser, either stop, force stop or force stop. So now when you click on that force, you are making that particular application being isolated for timing. So now same thing, that is Android is to define certain UIDs as isolated, prevents them from initiating RPC. Request to any but a bare minimum of services. So by making that force stop, so you are isolating the particular application. So this is the level of protection in Android operating system, coming to the Android mechanism. So we are discussed different levels of a protection or rings of protection with respect to domain specific, that is Android. So any clarification so far with the different domain implementations? Any doubt or? Okay. So for time being, this is enough. We'll take a small break and we'll come back again.